Hello, Vector Podcast is here. And today I'm going to be talking to Max Irwin. He's the star in the search engine business, in search engine world. He has been dabbling also in NLP a lot. I don't know, 20 years? It's a huge amount of time. And
Oh, no.
and I mean, he has been consulting in this space, also building products. And now he's focusing on building his new product. And he's the founder of a company called max.io, which is also a website. You can go check it out. And he's building a mighty inference server and a number of other tools that I'm sure Max will talk about today. Hey, Max, how are you doing?
I'm doing great, Dima. How are you?
I'm great. And thanks so much for joining me today. Vector search is on the blast. I mean, it's just such a journey. Everyone is doing so much. I've talked to so many people. I'm super happy to be talking to you today and learning about Mighty and all the things that you are cooking there. But I think as a tradition, could you start with introducing yourself first?
Sure. Yeah. Hi. So I haven't been doing NLP for 20 years. In fact, when I was younger, I didn't do so well in my language courses. I was more of a mathematics computer nerd. So I had to kind of relearn language and improve my language skills to be able to be dangerous in NLP. But I started NLP probably around 2014, 2013, depending on when I really first started hearing about it, getting interested. But earnestly really started in 2015, 2016 with actual product development around NLP. With search, I've been doing search since about 2010, 2011. Again, it's fuzzy when I actually first started, but I think the first real serious thing I did with search was when I went to take my first solar training course, which was when LucidWorks still had solar training and they had contractors come in and give training. So that was in 2012, but I'd been messing around with engines before that. And I started on an engine called DT Search, which was a C++ closed source engine, but you could buy the code for like $1,000 a year. So the company I was working for, MediRegs, we actually bought the code. And I was the newbie with search. I mean, we had guys who had been working with it for a while. And they built a whole platform around DT Search. And then it was starting to show its age, so we started shifting over to solar. But yeah, since I started that, but before that, I did a whole bunch of computer programs. So like the 20 years, 22 years-ish stuff that's in my bio, like I graduated university in the year 2000, and I've been, working professionally in software ever since. But with search, I really got interested in search around 2012 is when I really said, wow, this is amazing. This is so much different from what I'd been doing before. So that's when I really dove headfirst into the problem space and the domain.
Yeah. And some people say that many of us ended up in search field by accident, as well as actually NLP. I've been talking to one professor here in the University of Helsinki. He has built machine translation team, very, very strong one. And he has built the system called Opus. And he actually said that he ended up in NLP also by accident, because it was just an offer from a professor and he decided to take it, and he turned out to be quite good at it, But he also had another option, just to go and work in Germany. He's from Germany, to work in Germany in some company, database company. And luckily he didn't take that path. How was it for you? How do you feel about yourself and then ending up in this space?
That's a great question. It's interesting. I feel like ending it up, it was definitely somewhat accidental. I found I had the pleasure of meeting so many people in search through my different positions that I was working with and the varying degrees of expertise. I found that a lot of people who got involved with machine learning found out about search because TF-IDF and all that stuff is like an algorithm, and it's like, oh, there's this whole language problem behind search that we have to figure out. And then the search people get involved in machine learning because, oh, this language problem is horrible. How do we solve it with automation and learning? So I accidentally stumbled on it because I took it was a role that was in like healthcare compliance, and I was interested in that domain specifically, and search just happened to be a really important problem in that space. So that's how I kind of got into the technical domain of search. And it just was so much more fascinating than like the stuff that I was used to with CRUD, you know, just create, read, update, delete, and just workflow applications, which I'd been doing for, you know, 10 to 12 years at that point.
Yeah. Yeah. I mean, for me, like search, you know, like, I think I started 2002, 2003 academically, but then it was like 7 years passed and I still couldn't find a niche or a job for myself because there haven't been then many search companies in Finland actually at that point. And then I found a company which I joined in 2010, AlphaSense, and it was Apache Solr, Lucene, everything new, but it was still somehow inviting. And I think the first time when I've built the backend and I was like, okay, somebody is going to use this. Somebody is going to type the queries and will try to find information. So I also tried it out, and it kind of like maybe worked, maybe didn't. I wasn't the user of this system. I didn't know what to type. So I was just grabbing some phrases from the documents and see, okay, does it find or not, you know? So is this something that also like attracted you? Like, okay, findability, right? Like discovery, or maybe discovery is the next stage, but even the findability itself.
Yeah, I guess search was really my first step towards working with real complex data that wasn't so unstructured data, right? You kind of reach a limit with structured data at some point of getting stuff into databases, getting it out, and things like that. And you can spend a lifetime in that work, but I felt like I'd been doing it for a while. And with search, it was like this weird world where it's like all this unknown stuff and you don't know what to do. So it's this unsolved problem. I felt like databases and things like that were like this solved problem, where search wasn't a solved problem, and it still isn't. Now with the work, if I had been doing the same database work, that's all no code right now. You can just create the same stuff I was doing with no code tools. You don't even have to be a programmer if you don't want to, at the level that we were doing it, you know, in the mid 2000s. So yeah, now it is. It's still unsolved. Even when we start talking, you know, we're going to talk about vectors, of course, but vector search. But that's still an unsolved problem. It's like another tool, but you still have all these issues that you have to take into account.
Yeah.
So the endless exploration.
Yeah, it's like infinite quest in many ways, and there is like a limitless amount of tasks to solve. But then, so somehow in your career, there was a turn that you decided to get closer to this vector search field. I just wanted to hear your kind of first reaction. Like, what did you think about it? When did you hear about it? And also, what attracted you?
I'd say the first thing that really attracted me towards vector search was the BERT paper that was written in 2018, but I didn't come across it until 2019. And Google had written a blog about how they were using it for their web search. And you know, you could download some Python and get this stuff to work. But the reason why I was so fascinated by that is because of, you know, working in search already 6 years. No, let's do some math. So, you know, 8 years at that point. I had been stumbling along with the vocabulary problem, the query term dependence problem, as we call it, where, okay, well, to solve this, you have to create a bunch of synonyms, and then you get to a certain level of advancement, and then you create a taxonomy, and then you create a knowledge graph. And you know, before BERT, we'd started playing around with word2vec and saying, oh, can these type of embeddings be used to solve this whack-a-mole problem with synonyms and knowledge graph vocabulary expansion. The answer turned out to be no with Word2Vec. It didn't work as well as we'd hoped. It helped with some things, but it harmed with others. So it produced a lot of noise, and maybe we didn't give it a good enough chance, but we saw, okay, we can train this thing pretty quick and we can get this model from our content. But there's still this problem. So when I started to play around with some of the Python tools that were available for BERT and large language networks, which actually use Word2Vec as a pre-processing step to get the first encodings or the first embeddings, and then you use those identifiers to go forward. I really saw something there. I saw actual similarity where I just saw kind of co-occurrence with Word2Vec before. Yeah, these things you see them in the same context, but with actual linguistic similarity, the first time I saw that was with BERT. And that's where all the hype came from. And then the next step with BERT is like, okay, I have these vectors. Now what do I do with them? And then I said, okay, well, I have to use a dot product, or I have to use a cosine similarity. Okay, let me just do that. And then I say, oh, you can't just do that across every vector. It's impossible. You have to do something else. And then you go on this learning path, right? So that's where I ended up. And I had actually written a blog post in 2019, about, and I think that post was, widely accepted by the community. It's still on the Open Source Connections blog. And it was really showing like, hey, this is a change. It's not just Google that's going to be doing this. Like, this is really interesting. And a lot of people agreed, and there was like this movement that kind of happened after that. And a lot of other people were coming to the same conclusions, but there were a lot of challenges. So with vector search and approximate nearest neighbor search, that's just the tool to solve the problem. It's like, you start with this problem over here, and then you go like 10 steps over here, and finally you get to vector search. And okay, this is a potential solution, right? This is the core of the potential solution with all this stuff in the middle.
Mm-hmm. Yeah. But have you felt that I should read this blog, and we'll definitely link it in the show notes. But sometimes when I look at vector search, let's say demos or applications or algorithms, I get a feeling that you might just think, okay, I have a solution. Let me find a problem. because it's all semantical, and I mean, it's so sexy, right? Do you think this is one of the sort of misconceptions, in this field, or do you think that we are past that already?
That's a great question. I don't think it's a solution looking for a problem. I don't think that's true. I think it actually does solve some problems. But I do agree that it gets, there's a lot of gray area. And how do you arrive at that from, I need to find things as a person, and all the things that you have to go through until vector search actually means something as a solution. I think there's a lot of people who picked it up and say, okay, we could just use this and it's going to solve these problems, but it doesn't do that, right? Because search is not just about similarity. You can express a query similar to a document using TF-IDF, BM25, sentence transformer, cosine distance, whatever. But that's only the similarity. There's also like the need that the person has to what they have. So it's a bunch of candidate documents that are similar, but what's the actual document that you need? So that's where a lot of other things come into play. It's just one piece in a much larger search or recommendations platform. You still have to take in all the other signals, and common now in the more mature platforms is, you have some learning to rank algorithm that takes, maybe vector similarity is one feature in a learning to rank model, along with, BM25 with the title, BM25 with the body, the number of clicks, the date, all this other stuff. And it's a piece But the thing that the piece solves is that query term dependence problem. Whereas like, I don't have to, sometimes, you know, I don't have to go in and craft synonyms by hand, and I don't have this endless task of doing that. You kind of have all these other tasks that you still have to do, but that one maybe is kept at bay a little bit.
Yeah, absolutely. I mean, maybe I can a little bit like restate my question, or sort of like clarify what I meant. I guess when you read a paper like BERT or similar papers, they also say, hey, we ran down this on downstream task like sentiment analysis. We also did question answering. We did recommendation, all these other things, and it works great. Mm-hmm. Which kind of like pushes you to think in the direction that, is this a universal language model or approach that I can now take and apply to everywhere, every task? And the answer is actually no, because, hey, I mean, if you are in healthcare and they trained on news, it's not going to work. So the vocabulary still was not excluded from this journey. So if it is a mismatch, it's a mismatch. But the model itself, of course, is a clever piece of tech, which you can then take and kind of apply, fine tune maybe, or retrain on your data. So I think that's one way to look at it, right?
It is, but I think that we see still a huge gap in the domain, right? I think there are a lot of organizations that can just make use of pre-trained models and fine-tuning them. But I know that there are still domains that you can't do that. Like if you go up and you try, something that's fine-tuned, like law, right? Law is like its own language. I wouldn't even like law written in English. I wouldn't even call that English. I'd call that, legal English, right? Because just the structure, the vocabulary, the grammar, all this stuff is so different than what's in like a Wikipedia article or in the news or something like that, right? So when you try to do a fine tuning on a pre-trained model that's trained on, let's say like onto Notes 5, which is a bunch of collections of like, news, Wikipedia, like general knowledge that most people use. When you fine tune it, there's still a gap. There's something missing, right? Because the original trained model was lacking this context, and that's only for the content. Also, that's just the content. And when people search and they type in terms, you can imagine like this Venn diagram of like, well, here's all of the content over here that you've trained on, and then here's all the terms that that the users know, right? And you try to like bring these closer together somehow, right? If the model was trained on content that is like up here, then you're going to have trouble like kind of putting it together. I don't know if I'm doing a good job with my hands showing this, but
no, you're doing a perfect job there.
So I think that one of the big existing problems is pre-training still costs like a ridiculous amount of money and is out of the reach of most teams. I've read papers. One of them was by Microsoft showing like if the BERT vocabulary is like 30,000 words or something like that. If you increase the vocabulary size to like 100,000 words, then the model generalizes much better. And of course, you expand the content and the domains that are involved in that training. So I think we're going to see some more of that. The world is still stuck on this 30,000 terms in the pre-trained space of things like onto Notes, because it's just so expensive to train models. And Google and Microsoft and Facebook and these companies that train models, they're not going to bother open sourcing those. Maybe they will at some point, but I think we're going to need to see big companies that are specific in that domain train those models and then open source them. But if you spend millions of dollars to train a model and you're a big private company, are you going to open source the model weights? Probably not. You're going to keep it for yourself because that's huge value. It's huge value for your product.
I guess you open source the idea, sort of you publish, okay, here's the BERT model, here's the mom model or whatever, but then go train it yourself.
Yeah. Yeah. If you
Yeah.
have a couple $1 million lying around.
Yeah. And then I was also talking to, in another episode, Amin Ahmad, who used to work at Google, and he said that entire teams would be dedicated on a quarterly basis to do the expensive fine-tuning work with BERT or similar models. So can you imagine that it's like a team's effort, and these people, some of them invented the model, some of them didn't, but with all the resources that Google has to fine tune them for 3 months.
Yeah.
So I don't think this is out of reach of startups. And I mean, there are other things that are out of reach, like, and this is where you saw the gap with Mighty. I want to get closer to the Mighty now. So there is, every time I install a vector database, I'm not going to name one, and it says, hey, it will be faster if you use GPUs. And I'm like, okay, I'm a startup. I don't have GPUs. So this is, I think, one of the gaps that you saw with Mighty, but are there other gaps that you saw that you are addressing with Mighty Server?
Yes. So the NLP world right now and the vector world right now, all they talk about is Python. Python, Python, Python. Everything's in Python. When you get to production, you use something else, but it's Python, Python, Python. So I wanted to, I came from a non-Python background. I started with C and Pascal when I was really young, and then my C programming is terrible, I'm sure. Then I discovered, intermediately compiled languages, Java, C#, things like that. And that was like early 2000s for me. And I kind of I was in the Microsoft world, so I was doing C# for a while. And then I found, and all the while I'd been doing JavaScript because of, I was involved in the web in the mid 90s. And that's how I got involved with content and content data and all this stuff. It's just all web stuff. And then you got to know JavaScript if you do anything with the web. So it was like C# and JavaScript for me for a while. So I know that there's a gap. If you go into the JavaScript world and Node or TypeScript or those things, Dino now, there's nothing. You want to do NLP? Learn Python. That's pretty much the suggestion. Same with C#. Okay, well, there's some libraries out there, but they're clunky. Nobody really, Microsoft probably uses them, right? Because they're Microsoft and they built C# and everybody's doing Microsoft stuff. But outside of Microsoft, like, who's using C# for natural language processing to train models? Nobody. And to host models, okay, well, to do it, you have to jump through all these hoops, and it's really hard. So unless you want to like put Python in your stack, which is basically a non-starter for a lot of teams. A lot of teams, they work in languages like Node, JavaScript, C#, Java, Ruby, Go. Like, there's so many huge languages out there that just can't touch these models. So I wanted something that kind of broke out of this shell, this Python like enclosure of like, how do you get this stuff into the hands of other people who just want to build web applications? They don't want to go and, go into the Python family. So that was one of the starting catalysts from Mighty Inference Server. There is one tool that I have to use that is Python, because you have to convert a model, and I convert the model to Onyx, which is, most people know about Onyx if you're in the NLP world by now, it's ONNX, stands for Open Neural Network Exchange, and it's this intermediary format that can be used generically. It's like an open model format. Now, there are runtimes that you can take Onyx and Onyx models and run them. So the biggest one is Onyx Runtime, and that's developed by Microsoft. It's open source, MIT licensed, and that's written in C++. But there are bindings for other languages, and community contributes bindings. So you can use Onyx Runtime in Python if you want to. You can And you'll get like, for those Python people who want to host models in Python, just convert your model to Onyx and host it in a Python Onyx runtime. It'll double the speed of the model inference, like out of the box. You don't have to do anything. You press like a button. You clone the repo, you press a button, and twice as fast. But for others, you know, there's bindings for C#, there's bindings for Java, there might be bindings for Ruby. I haven't looked. Probably bindings for Go. And even if Microsoft doesn't support them, the community builds them. So you can do this, but there's this other problem that you have. The other problem is that, well, those are just the model weights. And if you're talking about and hosting the runtime for the model weights, so you put in inputs and you get outputs. But where do you get the inputs from? Well, you have to tokenize text and you have to do all this stuff to prepare it, to pre-process it. And then when you tokenize and you do pre-processing, then you can pass in the tokenized data as inputs. But all the tokenizers are written in Python. So now you have that problem. So I actually used Rust for Mighty Inference Server because Hugging Face based their tokenizer, their fast tokenizers, on Rust. They wrote it in Rust, and they offer bindings for Python. So if you install a fast tokenizer in Python, you're actually using Rust bindings for that. So I wrote a web server that wraps the Rust tokenizers and Onyx runtime, and I wrote a whole bunch of code for pipeline-specific stuff like question answering, sentence transformers, sequence classification, which is like sentiment analysis, token classifications, that's like entity recognition, and I'm working on others also. But that it's so much faster. It's so much faster than Python. Like, it's not even close. It's probably like 3 or 4 times as fast without any fine tuning of it. And I've gone through fine tuning. So if I compare it, I haven't compared it to Python in a long time, but I might be like 5 times as fast as Python right now on CPU. You can also use GPU if you want, and you maintain the same speed. It's just as fast.
Yeah.
Well, it's just as fast as the ratio of speed is like if you took the model in Python and you put it in a GPU versus you take the model in Onyx runtime and you put it in the GPU, you get it's far faster.
Mm-hmm. And you say, like, when you said bindings in other languages, you know, like Java, C#. So if my stack is in Java, I can take this model and kind of plug it into my Java code.
You can take let's take a Hugging Face model, for example, like let's say BERT-based uncased. You know, most people know that one. BERT-based uncased, you can export that to Onyx with Hugging Face code in Python, and now you have an Onyx model. Now you can, in Java, you can stand up a class that wraps the Onyx runtime, and you load the model into memory with Onyx runtime in your class, and then you can create methods around that class, right? And then you can call it, and you can say, I'm going to pass in the inputs and I'm going to get outputs, and that's all in Java now. Well, with the C++ wrapper for Onyx runtime, of course, but to wrap that C++ runtime, there have to be bindings between the language. So Java has to have some application interface to talk to C++.
Yeah, which is JNI, right? Java Native Interface, I think.
Yeah, I think so. Yeah. Java, yeah.
Mm-hmm.
So that part, like having Java talk to Onyx runtime, is taken care of already. You still have to write all the other stuff around it, to leverage it. But that's, we're programmers, we're used to that sort of thing. If you know Java, you can do that. And I think I don't know if it's I don't know how much we've seen it, but Jeff Zemmerich, who works at Open Source Connections, I know that he was working on a project where he could try to load an Onyx runtime in OpenNLP, which is a Java program. So trying to get an Onyx model in OpenNLP, and I think he succeeded. I haven't seen code for that though.
Yeah.
But that's one example.
Yeah, that's awesome. So, I mean, the reason I'm asking is because I witnessed this tectonic shift in my previous company where we had the entire stack in Java. Even though we started with Perl, but we had to rewrite everything into Java. It just didn't scale on Perl. And yeah, and I mean, we had Apache Solr on one end as the open source search engine, also written in Java. And when we would customize it, we would write plugins in Java and so on. But then when we wanted to introduce AI into the pipeline, of course, everything was in Python. We hired people who could only do Python, nothing else, fresh grads. And now you are stuck with this new architecture. Okay, you have Python as one step in the pipeline. How do you call it? How do you handle errors? How do you scale this thing, right?
Yeah.
And we were also moving to Kubernetes to add to this crazy mix. And what we ended up doing is that we would have a asynchronous processor plugged in every place where you have Python to abstract Python away from Java, right? So you would kind of like just say, send this message to an SQSQ, and on the other end, there is somebody consuming it. Can you imagine how scalable this can be? It works. You can also like scale it locally, but as the whole architecture, I don't think it's very kind of smooth in a way solution, like not to mention that the performance element of it is just not taken care of. And what you say now, essentially, like with Onyx binding in Java, we could just train that model and then export it in Onyx format and then use it directly in Java.
You can, yes.
Yeah.
But you still have to get the inputs to the model. So if it's like an image or something like that, it's usually pretty easy. But if it's text, then you have to tokenize first, and you have to use the right tokenizer, and you have to kind of jump through a bunch of hoops to get it to work correctly. So it's probably a month's worth of work to get a tokenizer working in Java the way you need it to work.
Yeah, and maybe you could in principle share this tokenizer between tasks, right? So like for sentiment or for entity recognition, in principle, you could use the same tokenizer. Yeah.
Right. So the tokenizer relies on the vocabulary and the configuration, which is bound to the model. So the model is dependent on these things. So if you have a generalized way to load the vocabulary and the configuration, then yes, you could just take the thing and use it in your new in your new stack.
But having said all this, with Mighty, you took a different approach. Like the philosophy behind Mighty, you offer it as a web server, right? And can you tell me more about it? I mean, I'm sure you can open a lot of detail.
Yeah, the reason I went that route is because when you want to do model inference, you want to give it as much compute as possible, right? And you kind of want it to be its own thing. So I went the microservice route. I'm not saying microservices are the way of the future and they're better than monoliths and all this stuff, but the idea of coupling this, this model inference as part of like your regular application code, maybe you don't want to do that. You want to have this other service that can, and this is part of like the bigger MLOps question, which is, well, how often should I update models? What are the things that I need to know about, drift and all these things that are like, what about logging and all this stuff? It's like, well, okay, you need a way to do this. And if you embed model inference in your own code, now you're also responsible for all this other stuff, right? So as a microservice, you can evolve that microservice and say, all right, this thing is responsible for model inference, and that's it, right? And then all the side effects around that of like, okay, well, you need a new model. What if you have to A/B test models? What if you want to do logging? What if you want to do all these other things? You can evolve that in its own way, and the separation of concerns makes much more sense. So, and then it kind of gets you out of the problem of like, okay, well, am I going to build Mighty for Ruby? Am I going to build Mighty for Node? Am I going to build Mighty for Go? Like, I don't have to do that. I can just build Mighty Inference Server as a web server, or a gRPC, which it's on the roadmap. I don't know how long that's going to take, but now you have this thing, and then I just have to write client libraries, and the API is always the same. The client libraries for HTTP are super easy. So, yeah.
And if you compare this, let's say we take a database like Weavite or Vespa, they have inference inside them, right? So like if you already bought into that solution, in principle, you could do this. The only caveat, I think, is that if you have your custom model, you'll have to go an extra mile to actually integrate it inside this database, right? And at that point, with Weavite, I think you will have to master Go. With Vespa, you'll have to master either C++ or Java. I'm not sure. I'm not an expert in that, but there is a podcast with Joe Bergum that you can check out. But yes, so how would you kind of like on product side, how would you compare Mighty to that approach?
So Vespa uses Onyx runtime. Vespa wraps Onyx runtime. I believe it's Onyx runtime. I know they use Onyx models. I don't know 100% if it's Onyx runtime. So you'd still have to go through the step of doing that. With Weavite, it's a little bit different. With Weavite, you have these things called modules, and then the modules are typically like Docker containers with APIs exposed, and then there's logic written in the module code for Weavite that will wrap that API. And it's easier if you just copy and paste the model and then change stuff to match the API of the thing that you have in the Docker container. So it's not that much work. You still have to know Go to do it. And yeah, I think the other problem that I have with that approach, and I'm not saying it's wrong, but from my perspective, so if you look at the documentation actually for a couple of vector search engines, I'm not sure of Vespa, but I think Weavite and maybe another will say, okay, well, it's better to use a GPU for inference and then CPU for the vector search, right? Because you want to provide as many workers to the search algorithm as possible, and you don't want the inference, the model inference, and the vector search fighting for resources, because both are very expensive, right? So they say, hey, if you have GPU, then all your model inference is in GPU, and your vector search is all in CPU, and you get this one perfect box, and everything just works. But okay, well, what if you want to scale beyond that? You can only send so many documents into a GPU at a time. What if I need 12 machines? Well, now I need 12 machines that are all hosting Weavite, and they're all hosting Mighty, or whatever your inference solution is, all at once, right? So this goes back to the separation of concerns problem. It's like, well, what if I have a lot of documents that I need to process, and it doesn't take that long to get them into the vector search if I have vectors, but processing those documents takes a long time. So I have to pre-process. Well, now you've kind of got like this situation where you might need another solution to do this batch pre-processing, right? In another place, and then you bypass the module when you integrate into Weavite. You just want to send the vectors directly into Weavite, so you don't have any inference. You're sending the vectors directly. So again, it's like this. I'm not saying it's wrong. I think it's a great idea, because you can just install something and it'll just work, right? You don't have to install like 3 different things and try to figure it all out. So I think that getting up to speed on that is probably quick. But in the long term, like the scalability overall, I think that you now have this coupling, and it's a bit of a challenge. So I don't know how that gets resolved.
Mm-hmm. Yeah, that's actually a good point, because you reminded me of, I don't remember precisely what we were sort of balancing between, but like with Solr and a Java pipeline in front of it. So the pipeline would process documents as they come in, chunk them, classify them, run sentiment analysis on them, and so on. we were thinking, okay, some of these things could be computed inside Solar. Like we could write some clever plugin which actually does. I mean, Solar has a lot of things there, like before it indexes a document, you can run like a ton of things. I think OpenNLP is one example, right? You could plug in and it runs something there. Um, and I remember that my manager, like who was a VP of engineering, he came and said, "Hey, what if we lose Solar?" So we computed everything inside Solar, stored it, and lost it. Then what? Like now you need to bring it up back really quickly. And usually what you want to do is probably like replicate some shard and off you go, right? But if you don't have that data, you need to recompute it now. So you don't have any intermediate storage. Solar is not the storage. Solar is the database. And so we backtracked and we said, okay, we will compute everything and store it in S3, in file storage. And if in the event of losing Solar, we will restore it and reindex everything on the fly. So, I mean, that kind of also resurrected that situation that also with Weavite or Quadrant or any other database, if you lose the database, you lose the vectors. So if you have computed them inside the database, now bringing it back and then turning it on and say, hey, please compute my vectors again, please, 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 just too much time.
You're exactly right. And this is a lesson that I learned. And I didn't learn this lesson the hard way, thankfully. But this is just a lesson I learned picking stuff up when I was at Wolters Kluwer, which is a huge publishing firm. And you have your content, which is like editorial content, primary source content, and it's it's written in such a way where it's pretty raw from a machine perspective, and then it goes through a series of enrichments and transformations till eventually it reaches the search engine. But every step along the way, it's like, okay, well, we need to add topics to classify topics, right? So I'm going to add the topics, and then I'm going to save that state that's now on disk somewhere, backed up. Okay, well, now I have to, add this other thing, do entity recognition or something. That's also saved, right? So you have all these intermediate steps. So if you lose anything, then it's like really easy. You don't have to rerun the entire. If you have to rerun the entire pipeline, it takes you months to do that. Not just days, but like literally months to start from scratch with content. So that's like a disastrous scenario. So this lesson that you learn is, okay, well, yeah, you don't do everything all in one place, because if you lose it, then it's all gone and you got to start from scratch. So yeah, separating concerns in that way. And then the idea of, well, you can plug this thing in anywhere along the chain now. You have a microservice, you can put it anywhere. And then you don't even have to just take the vectors and then stick them in the search engine, right? Well, what if you need the vectors and you want to do them for something else? What if you have like a recommendations platform and you have this other system over here and you want to do this other stuff? It's like, well, now you have to think about routing and all these other things. But if you just have an easy way to get vectors and you can plug it in anywhere along the stack, then that's up to you. There's no prescribed way of doing things. It's a Lego. You put the Lego wherever you want.
Yeah, that's a great point, because we also implemented like an algorithm which was it computing some topics, I think, and we used fast text and word to back vectors, but we didn't need the vectors in the end in the downstream system. We just computed them, clustered, ran some magic algorithm, produced topics, and then you store the topics. So you store actual words in some database, so index them in the search engine. So yeah, you're absolutely right. Like sometimes you don't need the vectors, but they are still the medium to get to your, to your target. So, and so, but I've seen the blog post, which will also link, you published on max.io, discussing sort of almost like a unit economy of this thing. Like if I have mighty gazillion amount of servers, how it will play out, how much separation of concern and also resource separation, all these things, and how economical it is in the end. Is this something that you are proposing? So let's say if somebody takes Mighty and wants to scale it, like all of a sudden you get, instead of 10,000 documents, you get 10 million documents to process, right? Because somebody changed somewhere in the pipeline and now we need to rerun the whole thing.
Yeah.
So how would you, what is your recommendation also on the economy side? How do you see Mighty playing a role in making this huge thing more economical?
So the first thing that I see is that you can calculate the cost ahead of time because it's absolutely linearly scalable, right? You take, so Mighty itself sits on one CPU, right? It sits on one thread. I'll even say a thread because these days you have cores and CPUs and threads and it gets messed up. You can tell Mighty to use multiple threads in certain situations if you want to, but the example for batch processing that I use, which I actually learned from the Vespa team because they wrote an amazing blog post in I think it was early January. They released a blog post talking about this exact problem of, do you have one process across multiple threads or do you have multiple processes? So if you go with the multiple processes route, let's say I take a bunch of documents and I pass them in, and I have some level of consistency in the document size, which you usually do. You pass them in, and it takes you X it takes you X to get all of your documents inferenced, right? So you have that number. You know how long it took, and you know how much content you processed in terms of bytes. Well, what if I add another process now, and I'm doing this purely parallelizable? So half of my documents go here, half of my documents go there. It's what I said exactly, is linearly scalable. I add a CPU, it halves the time, right? It halves the time that it takes to do this. So if I have a situation where I've said, okay, I did 10,000 documents, it took me X, now I have to do 1 million documents. How long do I want it to take? You can actually write down the calculation and say, I need this exact infrastructure, which is a huge problem right now. A lot of people don't know that. It's like, okay, let's just add a lot of GPUs and see what happens. You can spend the time to go through and do that calculation, but it's not so straightforward. And you'd have to do it like you'd have to cost it yourself. I haven't released it, but I want to have a calculator. It says how many bytes do you have, and how long do you want to spend? And I can say, well, it'll cost you this in Amazon or whatever. So that's one thing. I also want, so I mentioned GPUs, is like, I built it so it works on CPU. If you are a company that's getting into this stuff and this idea of unit economy, like how long does it take to process something, and what's the cost, and how do I scale it if I have a billion documents? If I'm coming into this ecosystem in content processing and I'm used to working in Java or C# or something like that, now you're telling me I need to buy GPUs, like I have to rent GPUs, and then I check the prices, I'm like, well, that's not how much we spend on infrastructure. That's not in our budget, I'm sorry to tell you. So maybe we can't even do this. So I wanted to have a way where you could get around that problem, where you could just use CPU and it's a straightforward understanding of the cost that you'd have to put in. I haven't checked Amazon prices in a little while, but Mighty is actually hosted on Linode, which is another cloud platform. The pricing is better, and I just like them. They were actually recently purchased by a huge content management system. It starts with an A. I forget the name. Whatever. Anyway, I use Linode, and it's cheap for CPUs. Like, it's great. But you want to rent a GPU? It's like $500 a month or $1,000 a month. And that's a lot of money for one machine. And most teams are not willing to spend that. If you want to do fractional, on AWS is probably fractional GPUs, I think. But it's still expensive. And now it's like this cost that never goes away. Like once you do it, it's like, well, it's there for a long time, CPUs are a commodity. GPUs, you have to fight with the with the cryptocurrency crowd for the cost, all this stuff. So
Yes.
yeah,
I mean,
CPU is the way to go.
I can imagine that GPUs can be used during the model training or fine tuning, but during serving, that sounds way too expensive.
Right.
Yeah, that makes a lot of sense. And so now when you offer Mighty, how exactly you offer it? It's a binary package, right? That I can install and basically run on my system, and I can decide whether it will be like a standalone kind of script or it will be a pod in Kubernetes or Docker image and some other non-Kubernetes. So is that right?
That's right. It's a very small executable. So Linux is a first-class citizen. Windows it'll run on Windows. It'll run on Mac. But I've heard people running it on Mac M1, but they had to like do a lot of stuff to like fix dependencies, and it wasn't really working that well. And I think what's it called, Rosetta or something? I think it's still using that like to do the x86 like bridge, like the translation visualization. So Mac M1, it's not. I wouldn't consider it working. I've also seen some other problems on Mac that I'm trying to resolve. It works fine. It works on my machine, right? That type of thing. But really, it's meant to be run in Linux. You can run it in Docker. It's really easy to get started in Docker. So you can download the executable and run it on your Mac, or you can just download the Docker and use that, which is probably a little bit more straightforward. And you don't have to worry about other dependencies. With Linux, if you're running it on Linux machines, you can use the Docker if you're doing like Kubernetes and that stuff. Great, run it in Docker. Just make sure that you sort out like in your pod or whatever, like how much compute you're actually giving it. Because model inference it's not just Mighty, it's like all model inference is really, really heavy. It's really expensive. It wants a lot of compute. Not so much memory, but compute. So just be sure to give it enough to satisfy your needs in due timing. I haven't done Kubernetes tests myself, but I like to run. I'm old school. Like this whole Docker thing. Yeah, okay. I'll make a Docker file. Sure, you can use it in Docker. It's on the Docker Hub. But I like to just install stuff the old-fashioned way. In Ubuntu, I'll just download the thing. It's a tarball, and you unzip the tarball, and you're good to go. The way you start it is actually it's a Rust program with a library dependency, which is on its runtime, because it's dynamically linked. It's not statically linked. But to start it, you can either start one core, you specify the model, or there's a thing that says it's called Mighty Cluster. It's just a batch script, and it'll look and it'll check how many cores you have on the machine, and it'll start a process for every core that you have. So it does this for you. And it takes like less than half a second for each core to start up. I actually put that in on purpose. That's a limit I put in to slow it down a little bit so it didn't like go off the rails. But you could probably take that limit off. You could just go and modify the bash script and see how quickly it'll start up. So so that blog post that you mentioned before, like I ran it on 128 cores. So it would take like, I actually took the rails off and let it start up really quickly. But it can take a moment to start it up on every single core. And yeah, you could do it in Docker, you could do it bare metal. If there's any people out there using Windows, I'd love to hear from you. I've heard some feedback from Mac and Linux, but I haven't gotten any Windows feedback. So I don't even know if it's worth building it for Windows these days. Maybe not.
Yeah, I think it depends. I don't know what should be the scenario is like you're a developer on Windows and for some reason you don't go on your server side to like you still want to develop everything locally, right? So you want to bring up, I saw such guys actually in my team. They wanted to bring every single server service on their laptop.
Yeah.
And that's how they developed. They didn't want to depend on any external connection.
Right. Even Docker is like a pain in Windows these days sometimes, right? So I know the Windows ecosystem because I used to be in the 2000s. That's the mindset. It's like I'm just going to run everything natively in Windows.
Yeah. And uh, like when I tried Mighty on Mac, I think it took like some seconds to boot, but the moment it booted, I was like shooting some queries and like to compute the vectors, and it was insanely fast. Is it only Onyx a secret sauce in this insane fastness in Mighty?
I mean, if you're used to running models in Python, it'll seem insanely fast. A lot of it is Onyx. They get most of the credit there. Yes. But there's a lot of other stuff that goes into it, which is like the tokenization and the pre-processing and the post-processing is just, it's fast. I've been using Rust for it, and Rust is a really interesting language. It's gotten me back into systems programming. I'm not here to say that like Rust is like the most amazing thing ever. There are things I love about it. There are things that are like, I don't know if I would do it that way, but you're supposed to do things a certain way because the compiler understands that it'll super optimize it for you. It's hard to wrap your brain around it if you're from a dynamically typed language like Python or JavaScript. It's hard to get a handle on Node. My compiled background, like type programming languages compile ahead of time. I was used to that from my previous life, so I was able to pick it up again. And I just read the Rust book. There's a free book out there. I actually bought a paperback because I like paperbacks and I like hardcovers, like actual paper these days. So I was reading it like that, and just going through the examples. It took me a couple weeks to get a handle on Rust. That gets a lot of the credit as well. The Rust language. It's just, it optimizes, and you have to learn this field that I'm in now with model inference. It's like this super niche field of like, you have to understand the hardware and you have to understand machine learning. And those two fields are like so different. There are very few people out there that are really good in both. So I know that there's a word vectorization. So vectorized on the CPU is like, well, if I have to do a calculation with a byte, and I have a register, it's 64 bits, but I have an 8-bit byte. Like, well, I can vectorize and I can do 8 calculations because it's with SIMD, same instruction, multiple data, right? So Rust, if you turn on certain compiler flags, it'll do that for you automatically. So you get that speed up. So I turned those knobs all the way up. I said, use AVX 1 and 2 if the processor supports it, and most processors do these days if you're on x86. ARM has a different set. I haven't gotten into the ARM world. I have to get an M1 Mac, and I'm going to start messing around with all that. But if you know that stuff and you know how to turn it on, Rust does the rest for you. You kind of have to write your code a certain way so that Rust will do the optimization a certain way. You can't think like old school. You have to kind of think in Rust world a little bit. But doing that, now you get all this extra speed from pretty much nothing, just from writing your code a certain way and turning on a couple of compiler flags. That's why it was so fast.
Yeah, but you still needed to figure all of this out. And I remember you were saying that you had a bunch of weeks, coding nonstop.
Yeah.
To get things done, because I know, and many of us probably know here in the audience, that if you are a programmer, you might say, yeah, I can do it, but you cannot actually estimate when you will be done. And so you get into the weeds and like, oh my God, it just like UTF or something else doesn't work, or like I'm sending a request, it fails, whatever, what's going on? And you spend so much time, or if you're doing an algorithm, that's another story. That's like an infinite journey there, like debugging all these states. And I mean, I'm just trying to say that even though you make it sound so easy to master Rust and to go through all this maze and make it the way compiler wants it, it's still time. It's a lot of time. It's skill, and so you mastered it, and that's why. And in the end, the end result was not given. You earned it, right? So why not turn this into the business? So now on the business side, I'm thinking, how do you offer Rust? So how do you offer, Mighty? So you have you have the binary, you have the like the model will be shipped separately somehow outside of binary, right? But what as a customer I'm paying for? And yeah, and also kind of ahead of time a question, can you give a discount code for our audience to try it?
Oh, that's a great question. Uh, yes. So my business model is again old school because I've been doing software for a long time. So it's licensed software, right? You pay a license, you get to use the software. I'm still trying to figure out the exact price point. Some people say it's too cheap, which is interesting because I didn't think so. Some people say I should charge more money for it. It's $99 a month right now when this podcast is published, and after that, it may change. If you get it, I don't have, it's wired up to Stripe. I can go in and create a discount code for folks. I don't have a code right now, but if you email me and you say, I heard about you on the Vector podcast, follow the link in the description, like follow the link in the notes, and Dima will set something up so you can get a discount. That's the way it works. But that's for commercial. So if you're using it commercially and you're making money from it, then I ask you pay a license, please. If you are a nonprofit, charity, or just using it, you're a student, or you just have a side project, you're messing around, you just want to get some vectors, go ahead, install it. Don't worry about it. But if you put it in production and you're charging money for your product, then please buy a license.
Yeah. Tough question, Sign. How will you track who is using it for commercial and who is using it for a hobbyist project?
That's a great question, and I don't track that. I'm really into privacy and safety on the web. So I don't like the idea of like putting in a whole bunch of tracking and telemetry. I think that's a terrible way to run a product these days. The only thing it does is I have it ask, when it first starts up, it just asks the server for what the latest version is, and it'll tell you if there's a new version. So with that, I see that okay, somebody asked for a new version, and I anonymize all the IP addresses, so I don't even know who. Like, there's nothing. There's no user information at all. So I just use that to kind of track how often it starts, and it's I see like maybe 5 downloads a day right now. That's what I do. So if you're running it, if you're pirating it, I can't stop you. Spending my time trying to stop you, it's not worth my energy.
Yeah,
I'd much rather work with teams who really want to gain something. So if you do buy a license, I'll work with you on setting it up and telling you how to use it and working on it with you. It's not advertised, but around model inference itself, I'm happy to offer services to get your model up and running and making sure that it's running optimally. Even doing a model conversion with you, setting you up with that stuff. But that's not advertised. It does say like we'll spend an hour with you if you buy a subscription to get you set up. But if you need more help than that, let me know. Now there's another tier, which is like, if you're Amazon, Amazon would never buy Mighty. They have their own world. But if you're like a cloud provider, or if you want to offer it as an API, that it doesn't count because it's per product that I sell the license for. So if you are selling it as a cloud provider or as an API, and you've got like 1,000 clients that are now using Mighty, well, I actually count all of those clients as a Mighty user. So I don't have a price published, but if you have that situation, I'm not going to charge you $99 a month for each client. That's if you're running that type of business, contact me and we'll work something out.
Yeah, that's perfect. I mean, sounds like a solid model. I mean, for the start, for sure. And another like favorite question I have, and I've been asking this question also to open source players like Weavite, and I think Quadrant. So basically, have you thought, one way of kind of building that connection that may yield a business case for you is what you just explained, right? So somebody buys a license and then you scale with them, you explain how to make it better, how to tune it, maybe implement some features. Another route is to open a Slack channel or Discord, whatever, and invite users there and then start talking to them. And maybe you'll have some open source components as well at some point. I don't know, a tool that helps me to convert my model into representation that Mighty can read. Have you considered also taking that open source route as one way of building that community, of some of which will be your users and paying customers?
Great question. I don't have a I don't have a Slack. I don't have a Slack myself. I'm a member in many other Slacks. I could set up a Discord. I'm on Discord, mostly just for the MLOps community in Discord. But I could just start like a thread or a channel in that. I don't know if Mighty itself needs its own Slack by itself. I think it's more of a community. It would be part of another community. One of the annoying things for me is I have to go and join like 12 million Slacks because everybody has their own Slack, and it doesn't work with one another. Discord does that way better. Slack, we got to have words. You got to make it easier. I have like 4 email addresses or 5 email addresses on across like 12 different Slacks right now. I can't keep track of them. But in terms of open source, I already have a bunch of open source projects. So there is max.io, but spelled out maxdotio on GitHub. Somebody already took max-io. You can't have dots in GitHub names, but that's fine. Names are names. So there's Mighty Convert, which I'm working on updating that because it's based on Optimum, which is a Hugging Face repository that does model conversion. It's a very light wrapper around Optimum. It basically just converts the model for you, bundles the tokenizer and a configuration. That's it. It's pretty straightforward. You can do that yourself. You don't have to use that. But that's open source. There's also Mighty Batch, which is a node program, which is a way to do concurrent batch processing of documents into vectors, pointing it at a Mighty server. That's best described in the blog post that I wrote of how that works, about the blog post being converting the Code of Federal Regulations. It's on the homepage of max.io. And there's also a bunch of other open source projects that I haven't talked about yet. So there's now Node Mighty, which is basically just an API client for Node that will talk to Mighty. It does connection pooling. So if you have like four Mighty cores running, it'll talk to it'll negotiate which core to use when it makes a call. So that's really easy to use in like an Express server. I also wrote 2 other Node modules while I was at it that aren't for Mighty, but I wrote Node Quadrant. So now there's a Node client for the Quadrant vector database. And I told the guys at Quadrant that this exists. I'm trying to work on a blog post of how to announce it. I guess this is the announcement. But I'll publish something. There's going to be a demo. I also wrote Node Pinecone. So, it's Pinecone-io. So now there's a Node.js integration into Pinecone. So you can talk to Pinecone from Node, from like an Express server or something. The guys at Pinecone don't know that I wrote that yet because it wasn't. I just put it out there. It's on NPM. So I gotta work that out. And they might want it. If you want this, I just wanted something that I could use. But it's your name, so please take the package from me. If you don't get upset that I used your name, I just wanted a tool that I could use for my own Node.js testing. But then this stuff integrates with Mighty really easily. So I have all these Node clients now, and I'm focusing on JavaScript first. So all this stuff is going to be released. It's already up there. It's on NPM. It's on my GitHub. It's free to use. maybe needs a little bit more polish. I haven't fully mapped out the APIs. I just mapped out the core stuff that I needed to do. So it doesn't do things like the scroll command, where you can scroll through all the points on Quadrant, but I don't know how much of a use for that is. It's really easy to add that. I just didn't have the time. So yeah, there's a bunch of open source work that I've been doing. I also want to mention I'm working on starter applications. So I have right now, basically it's like a starter app that works with Node, Mighty, and Quadrant, and also Node, Mighty, and Pinecone. I have 2 starter apps that aren't released yet that I'm working on polishing up and getting out there, where it's really easy if you're a JavaScript person to just take documents, convert them into vectors, load them into a vector database, and have a search app running using them.
Yeah, that's fantastic. I mean, so much to unpack, and I think this could be one of the we are witnessing a community written software for a closed software company. I mean, Pinecone is a closed software company, right? And we have an episode with Greg Cogan, who is a chief marketing officer with Pinecone. We can connect you two, and you can discuss the future.
I've talked to Greg.
Awesome.
We're working on some stuff.
Awesome. But what my question is, what made you write those connectors? Like, did you think that this would also pave the way to using Mighty, plugging in Mighty in the pipeline? Let's say if I'm a Pinecone user and I can have a Node Pinecone connector at the same time as Mighty.
I'd say half that. There is, I do want to promote Mighty, of course, but again, I want to bring these tools outside of the Python ecosystem. If you look at the vector databases right now, with the exception of with Weavite does a great job of having different clients for different languages and stacks. Vespa as well, but both Quadrant and Pinecone right now, it's all Python. Like Quadrant is written in Rust, but their client right now is their first class client is in Python. Which they did that because obviously everybody who has to get vectors has to use Python anyway, or they used to. So that's why they chose Python. At least that's what I speculate. And Pinecone as well. All of their examples are in notebook form, in Jupyter notebook form. You go in and you want to do a semantic search example, that's a Python notebook. I'm not crazy about Python notebooks. I think Python notebooks are good for illustrating like ideas and sketches for papers, but it's really hard for me to look at a Python notebook and say, here's how I make this into a working application. It doesn't translate well because the architecture isn't there. It's a bunch of cells that you run in order. That's not how real world applications work. So the idea is to just get these tools and get these ideas and capabilities out into the hands of a lot of other people who want to be able to use this stuff and are not familiar with Python. They're not familiar with NLP, but they want to be able to use this new technology because they might have a business problem they're trying to solve.
So you're thinking actually about engineers who are day-to-day productizing their code and thinking, okay, yeah, I need the embedding layer, but I don't care about notebooks. I'm not a Pythonista or whatever. So, just give me the tool.
Exactly.
Yeah, that's fantastic. I mean, and by the tools, you also like disclose something like ahead of time with me that you are like one of the overarching goals for you is to develop as many tools for the vector search community as possible. And like some of the tools you mentioned, like go beyond, pure engineering components like connectors. You said maybe like fine tuning a model or something of that sort, which at that point, I think you're stepping on the ground of, other startups like Gina and, DeepSet and so on. Do you feel that way, or do you not concern yourself with those and you're just thinking, okay, what's missing in the field? I'm going to add it. I'm going to open source it.
Yeah, same. So DeepSet is like, it's all Python again. Gina, I think, is a lot of Python, right? I'm not as familiar with Gina, but
they're Python mostly.
Yeah, there's a huge opportunity to make these tools available to non-Python stacks. And before I started working in machine learning, I'd never even considered Python as an application framework. You know, people were using like Django and Flask and stuff like that. But for me, it was like, it's not that I didn't take it seriously. I just felt it wasn't something that I would have chosen to use aside from, you know, a lot of other stacks. So there's so many other teams out there that want to be able to use these things, but now they have to, Python, Python, Python. It's nonstop. So we got to break out of that somehow. And I'm starting with Node because the JavaScript ecosystem is just absolutely enormous. I think people underestimate the size of the JavaScript ecosystem. If you're in machine learning and you're listening to this podcast right now, like there are like maybe 100 people for every one of you who's using JavaScript for applications. Like that's how big it is. So that I'm starting there. I just know it's just an enormous community.
And not only for front-end development, you know, we need to emphasize this because you also have server-side JavaScript like Node.js and others, and it's huge. And a lot of software, which is kind of the middleware between your super cool search engine or your vector database and the front end, you have a lot of middleware written in Node because it's so much easier. Well, not easier. I don't know. Is it easier? But I think it's just the pervasive, you know, nature of JavaScript.
Yeah, I don't know if I'd say Node is easier than Python. I think it's, you know, I think they're similar actually in a lot of ways. The syntax is a little bit different, you know, curly braces versus tabs. Yeah. But I think that Node, we're getting away from vectors right now, but Node started because JavaScript was the language of the web, and people didn't want to learn another language to also write backend code. You know, you were using Perl, right? So there was a lot of time where it was like Perl, PHP plus JavaScript, right? There was that whole world out there. So that's where Node came from. It came from the web front end. So web front end is enormous, and a lot of them just adopted Node. And then Node had its own hype cycle, like 2010 through 2014 was like maybe Node's heyday, where it just was like through the roof. Everything was Node.js. It was going crazy. Now it's all you know, machine learning and AI. A lot of people got involved in this world, but there's still a huge section of the world that's written on top of Node, from applications that started in you know, the early 2010s and have evolved ever since.
Yeah, but back to tools, like, so you said in the early notes you shared, like you also want to address some of the unsolved problems, like in model fine-tuning or some other like pipeline steps that maybe precede the embedding layer that you have now addressed with Mighty. So what are your thoughts there? What do you think is missing?
I don't know if I'm going to get into actual model tuning. I think that first of all, I'm not as good training models as other people. There are other people that are suited to train models, but I do think there's a lot of other information that is lacking in the MLOps world and vector search. One of them is just like, well, how similar are these things, right? What's the distribution of similarities? I think Weavite said they do support some of that, and Vespa supports some of that in logging. But I don't know about Pinecone. I'm pretty sure Rust. Pretty sure Quadrant does not. So it's like, what do I mean by this? It's like if I have a vector and I do a query against Quadrant, for example, I get back a list of documents that are nearest neighbors and the similarities. Well, where does that fit? Like if I get it back and the first document is like 0.49 similar, right? Is that good? Is that bad? Like what's what's real good similar? Maybe the best similarities are like 0.8 range. So now I know that, well, in terms of my entire corpus and how people usually query, this result is actually not that great. And there's a lot of questions to be answered around that stuff. So I think that's lacking in a lot of ways. I don't know if that's the right fit for Mighty though. I think those are just external tools that, I'm kicking around. All that stuff would be open source. I'm really interested in Mighty being the area of the business, and then all the other stuff is open source to make things easier for people to use these things. But yeah, there's a lot of stuff in terms of in the MLOps world. There's like model drift. It's like, well, I used, if let's say I have like 100 sentences, right? And I vectorize these against, model 1.2.3, right? And I got back a list of vectors. Now I've upgraded my model. I have model 1.3.8, right? And now I run my test vectors, my test sentences through, and I get different vectors. Like how much has changed? What's the difference there? So there's this whole world around measuring model drift, and there's some interesting open source tools on this already, but they're written in Python. So now you'd have to use Python to do all this stuff. So I'm trying to understand what the tools, what tools could be written that are not in Python land, that could expose these statistics and this important information to people who, who don't want to marry themselves to Python.
Yeah, absolutely. It sounds like you touched also on this very important topic, which I think is known as a metric learning, where like on one hand, you do want to know what is the optimal distance, and maybe you need to fine tune your model, and maybe your data is not a good fit for this model, and so on. But you do need the tools, maybe something like Cupid for, ranking evaluation and tuning. You would also have some tool which is Cupid-like, maybe even with the UI, where you can load these vectors, visualize them, and see, okay, how do they fit together, what's missing, and so on, and then have the stats on it, right? So you can actually run the statistics, and I'm
going to let Eric write that tool. I love Cupid. Cupid is so great. Eric, go write Cupid for vector searching.
Yeah, I think we can pair up on that. Maybe all of us contribute, make it open source. But yeah, I think this is one way to look at it, right? And I think Quadrant developers, they push the metric learning quite heavily forward. By the time this episode is out, there will be another episode with a developer from Quadrant who is actually very big on this idea of metric learning. And he open sources, of course, everything. And I mean, he offers tools and also like papers that you can read and educate yourself on this space. I think this is something that barely is scratched at the moment by the community, by even the end users. They don't know. Okay, I take clip model, I have the images, plug them in together, works fine, I'm done. What if it doesn't work? What if you have some images, you never find them for any query, but you do want to find them because it's an image of some product that was recently released and you do want to showcase it, right? And you're not using keyword search there. It's an image. You're using vectors to retrieve it, right? So things like this. I mean, it's kind of like there's a bunch of topics there. Another one favorite that I like is the robustness, right? So if I have an aircraft, I rotate it a little bit, and all of a sudden I find kittens instead of the aircrafts. And this is what Connor Shorten showed yesterday on the Gina meetup, and it was amazing. I mean, robustness. You just change slightly your input, and you just doesn't work. So I think there is a lot of things missing, but from what I sense in your answer, like it feels like you do still want to keep your focus on Mighty and push that as further along as possible, right?
Yes, and what I really want is I love that people download it, install it, and use it, and do whatever they want to get vectors with Mighty. That's awesome. I'm really trying to find partners. I'm really trying to find partners who want to just really make it super easy to do model inference at scale. So if, for example, I haven't gotten any replies. I've been like spamming, not spamming. I've been emailing and trying to get in touch with like cloud providers, right? To say serverless inference. If you could offer serverless inference, right, through Lambdas or whatever, that's like, so many people are asking for that, you know? You can't do that with Python tools these days. You can do it. It's just gonna, it would take forever and it would be really expensive and really slow. But there's such an opportunity for cloud providers to make it super easy. So you can have, you know, you want to get content from point A into your recommendation engine or your vector database or whatever, you know. Do you want to stand up like a big GPU server in the middle to get this? No, you don't want to do that if you can avoid it. So how about something that's serverless and people could just run? So I'm trying to find partners there. I'm trying to find partners who have search platforms and other platforms, or just see this as a Lego in their stack and thinks it's going to make it easier. And they don't want to, you know, hire a team and spend months building this thing and trying to figure it out. You can do that, of course, go do that, but you know, you can save yourself a lot of time and pain by working with stuff that's already there.
Yeah, that makes sense. I mean, probably companies like the likes of Algolia or
right, exactly,
potentially Elastic, you know, because they both of these want to get closer to the neural search, even though maybe they were not wired up originally to be vector search databases, but they do have the components like Elastic based on Lucene and Algolia probably based also on Lucene. I'm not sure, but I'm sure that they're looking at this field. So, I mean, for them, and now we are getting a little bit into MLOps and vision that you also shared a little bit ahead of time, that Mighty could be one of the components in the MLOps ecosystem, right?
Yeah, absolutely.
Not just a standalone kind of script which I download and then I'm thinking, okay, where do I plug it in? Right? I mean, if it was, are you thinking in that direction as well yourself? Like, okay, identifying the tools and systems where Mighty could kind of like play along a role of the embedding software.
Yeah, absolutely. I have to, the other thing I want to figure out is, does it make sense as it is right now as a web server like that for every case? Probably not. There's probably situations. gRPC was one request that I have to figure that out. So that makes it a little bit easier to bind it to certain application layers. But yeah, it's meant to be flexible. For you stick in a model that's your model, you know, and you run it how you want. The other thing that I found was that I met a lot of people who were like scratching their head saying like, which model should I use also, right? Is my first model or whatever. And I just want to start playing around with this. So that's the other thing I did is I have like default models that I chose that I know work well, because, you know, especially like Niels Reimers, he's amazing and he's done amazing community development around Espert and the models that he's trained and the documentation he's published around why certain models are good and others are bad. So other people, they don't know of this stuff. So it's just like, well, you don't have to go off and learn and understand right away why I should choose one model versus another. It's a hard decision to make. So there's some defaults that I chose. So it's really easy to get started. So the vectors themselves right off the bat, or if you do question answering, it'll be pretty good, like for regular English, not domain specific. You still have to do fine tuning for most cases, but you're not going to start fine tuning before you even know how this thing performs, like in the beginning, right? You want to try a model and see how close it is. So there's some starting work there. I know Algolia is getting into the vector search stuff, so I don't know. Maybe they don't know how to choose a model. So you can use my default model if you want to. It's just
yeah, absolutely. I mean, so far what I hear from you is that Mighty has the qualities. Let's say it can run on pure CPU, which is a win on cost. It scales, which is also a win on cost in the long term, right? And it also is insanely fast, which is a win on product. It's a win on go-to-market. Like I have this document, how quickly it travels through the pipeline and is searchable, right? So, I mean, it's important use case. In some cases, like paramount, like financial space, a document came out, I want it to be indexed right away, like a second after. I don't want to wait 5 minutes. It will be way too late for me to make a decision. So, I mean, is there something else like you, and maybe if you could compare now or point us to the blog post, with other vendors, like Amazon has Inferentia, Hugging Face has Infinity, right?
Yeah.
And then NVIDIA, I think they also had some layer. I forgot its name, but like those are probably fairly expensive. They probably are not $90 per piece. So what is your thinking there? So like I think you also are vocal in this space, or like in that direction, that Mighty is much more economical than these more expensive solutions, but they probably offer something else as well. But like you have a niche for sure.
Yeah. I think that, so the interesting thing, if you get involved with like, if you get into Amazon, like Inferentia and all this stuff, they crafted like their entire, like they build their own hardware. They have their neural core that all this stuff is based around. And that's like, it's lock-in, it's big time lock-in, right? This is just a web API. You can just use it. I think that I've considered also like hosting an API like Hugging Face. Hugging Face is like one of the most amazing software companies ever. It's like, that's like the real community driven open source stuff. They do such amazing work. So I don't want to say anything bad about Hugging Face because I really have nothing bad to say at all. But Infinity definitely has a fit for the market, which is like, if you are like Walmart and you need a solution, okay, Hugging Face Infinity is in your budget, go pay for it. That's the type of thing that Walmart should use. But if you are just like, if you're a 5-person developer team, or like even if you work at a company that's like 300 people, Infinity is like really, really expensive. So there is a market segmentation there. There's a difference between, okay, well, how much can you afford and who can you hire, and what's the level of internal support that you have to put around this thing, and how does it all fit? The teams that are just starting off that need to use something that works, it's really fast, it's easy to use, then that's where Mighty fits. I don't think Mighty competes with Infinity, because honestly, hey, Walmart, if you want me as a customer, if you want to buy Mighty, sure, go ahead. Let's talk, or you can pay the $99 a month. But that's not who I'm targeting. I'm trying to make it super easy for everybody else.
Somebody high rank recently connected with me on LinkedIn. I think some kind of VP of engineering. Hey, if you're looking into embeddings, contact Max.
Really?
But like, so we understand Infinity a little bit better, because I didn't try this at all. Is this like some kind of web service that you basically buy subscription for, like SaaS kind of thing?
No, it's like a Docker container. I think Infinity is a Docker container. I don't know. It might even be written in Rust. I'm not sure. Consider tokenizers are written in Rust. They may have done. I may have done some. Infinity came out before Mighty, so they may have done something.
So it's a perfect competitor for Mighty in that sense. I mean, not on pricing, but I mean on
Right.
the package itself, right? So basically,
Yes.
it's like Docker. Anyway.
Yeah.
Yeah.
And I think Mighty, well, I think Infinity encourages GPU. Like they want you to use GPU for it. But that's like, I think Infinity fits well if you have like, 1 million requests an hour, something like that scale,
Yeah.
If you have like 20,000 requests a day or 1,000 requests a day, that range, 100,000, I think Mighty's perfect for that. It's not, you don't have to have like this huge scale. It can get bigger. You can just, spend more money on hardware and scale it up as much as you want. You can support, 1 million requests a day if you want to, or 10 million. You just have to put more hardware behind it. So I think I'm just competing in a different market. I don't think Infinity and I are targeting the same businesses.
Yeah. And I mean, you do have the edge on the fact that you want to address the community beyond Python. So like, yeah. I think it's a big message to send. In some ways, through you channeled this feeling that, hey, these guys in Node.js or Java probably feel like left out from this big thing, but it's probably not true. I mean, I know also there is this deep learning for J and blah, 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 but like, it's like an island in the ocean probably compared to what
it's amazing software. It just didn't get the adoption that Python got.
Yeah.
I remember going through these internal pains myself, right? When it was like 2015, 2016, and I started getting deep learning training, and I took Coursera courses, Andrew Ng's courses on machine learning and stuff. I started off with Octave, which is an open source, is it Mathematica or whatever? It's GNU Octave, but it's its own language, right? So it's mathematics, just as code. But then like the next courses were all Python. And I was like, oh no, I have to learn Python. I don't know Python. I have to know a new language to use this stuff. Okay, fine, I'll do it, right? So I went down that and I learned Python and I got pretty good at it. But there's a lot of people who just don't want to take that step. They want to ship code in their stack. So it's a big ask to say, if you want to use these awesome tools, you got to convert your language.
Yeah, exactly. And if you're not into data science or machine learning, then why would you enter Python at all? Like, it has no like single winning point compared, well, maybe simplicity, but hey, is that it? And then it's like loose typization. Of course, you can make it more strict with typing and blah blah blah, but like still. But like it took me actually good 3 years to learn Python properly, because it's like not like, okay, oh, I understand how to do the for loop, I understand the indentation and blah blah blah, but like to actually master it, right? Like avoid stupid loading of the model multiple times in GUnicorn. So I think like Python, I didn't enter the Python world, luckily. But even just writing normal software in Python takes a lot of time. Productizing it takes a lot of time. So why would you enter it if you are not after the tasty machine learning and data science? So why would you consider even converting your software stack into this? So it should be the other way around. And I think you are doing a great job there with Mighty, basically offered as a service, or offered as maybe in the future as some kind of library or some kind of environment. I mean, Microsoft has been doing a bunch of these things. I don't know if you remember the CLR, Common Language Runtime.
I do, yeah.
So like you bring up the Visual Studio and you can say, okay, my project will be in Perl, compiled and run for Java. I don't remember. It was crazy. I was just experimenting with it, and I was like, I barely knew any of these languages as a student, but I was fascinated by the idea. It didn't fly, I think, but it was amazing.
Yeah, absolutely. And I did play around with the idea of, well, what if you don't even have to download Mighty? What if I was playing around with this idea from the NPM perspective. Like, what if you just installed it from an npm command? And I thought, that's a little bit heavyweight. Do I want to bring in this thing from, I could. I don't know if I should do that. And I also don't want to set false expectations too. And maybe this is just because I'm not great at marketing, but I don't want to set the expectation of you just do npm install mighty server and then you have a perfectly running thing, because it's more than that. You have to scale it properly. You have to give it its own compute. You have to choose the appropriate model. You have to do certain things to really get the most out of it. So I don't want to set false expectations where somebody deploys it and it's like it doesn't work well at all because they just did npm install mighty server, which doesn't exist, by the way. Don't try that. And then it didn't work. So I there is a little bit of knowledge that you do have to attain. So I want to ask, you do have to familiarize yourself with some concepts. That doesn't mean learning an entirely new language and stack.
Yeah, it's more like probably like MLOps or DevOps, so somebody can pick it up. And I mean, learning that way is much faster than actually, figuring out how the hell will I plug it into my Java code or C++ code or whatever. So yeah, of course. I think I've really enjoyed this conversation, Max. We went deep into all these aspects. Maybe not. We can record another episode, going in another direction. I'm sure there is like million directions to take. But I enjoy asking this question of philosophical why. If you can still spare few minutes, like why are you fascinated by this field of vector search? What brought you into it? And I remember, I will also make sure to mention this, that we did form a team with you, and you responded positively to my inquiry to compete in billion scale ANN competition, and you basically single-handedly almost driven the idea of body PQ. Of course, we also have Alexander Simonov who was helping you, and all of us been brainstorming with you. But so that was kind of like maybe academic fascination with it, right? But are there other facets that keep you going, also giving your background in search, which was pre-vector search?
Yeah, I'd say just my endless curiosity into things. I think a lot of us have that as, if you're listening to this podcast, the audience, there's probably a lot of you who are very curious about just technology in general and the limitations of technology and what's possible, and getting to that new magical thing, and trying something for the first time and saying, oh my God, this is incredible. I can't believe this actually worked, that I did this. So it's that. I mean, I'm in my 40s now, so I've gone through that cycle a lot of times where I've tried something and it was amazing. I do really feel that there's a lot of practicality to it, though. In my wisdom now, I see that, just because something looks cool doesn't mean it's the best thing in the world and it should be used everywhere. So I see the practical use and need for vector search. Whether or not it turns out to be like the end all be all with search, that debate is open, right? But I don't think it is. I think it's just one piece in the puzzle. But it does solve this whole class of problems that were unsolvable before. If you go back 10 years, when I first started in search, the types of things that I'm doing right now, and I'll give you an example. And I actually, I said this to somebody the other day. It's like, the first time I installed Solr, this is even, maybe Elasticsearch was around at that time, but maybe it was Compass Search. It wasn't even Elastic yet. The first time I installed Solr and I put in some documents, I was like, wow, this is amazing. Like, I can do a search. This is so much better than that crappy index that I was using on SQL Server. So it was just really, it was like that type of amazement. But then you work with it over time and you see the limitations, and it's like, oh, God, I had all these synonyms and all these other problems and all this stuff. I'll say that, when you first start off in like the relevance of Solr, like out of the box, you take their example schema XML, and you add some documents to it, and you get back stuff, and you're like, okay, this is cool. if you take that feeling and then and I'll just use Quadrant for an example, because Quadrant is, in my opinion, like super easy to use. Like you just Docker pull Quadrant and you throw some stuff in there. Especially now with this node thing. So when I did that, the first time I used Quadrant and I wrote this node wrapper and I just chucked in a whole bunch of documents, I saw that like just the out of the box relevance, and I'm not saying this is fine tuned, like this isn't something production worthy, but just the out of the box relevance, I was like, this is better. And I would spend, in my opinion, less time worrying about this than I would with an inverted index, you know? Just because, well, yeah, maybe the results aren't like super precise all the time and things like that. But if I'm on a team and it's like, I got this search bar and I got this content and I don't want to worry about it, right? I don't want to worry about it. I just want it to work. I want it to surface stuff that's like reasonably accurate. It doesn't have to be the best search in the world, but it's a cost for me. It's a cost for me as a team. I don't make money from search, but it's something I have to support. I think vector search offers a really, really good solution there, because it's not like you have to chase that endless bug of this doesn't even have anything to do with my search. I searched for, what is the best hiking boot or something like that, and all of the documents, they matched what? 10 times, but there's no semblance of hiking boot or anything in my document. This is terrible. You don't get anything like that in vector search. And that's, I think, the appeal. When you get into like real production, like highly tuned search, it's just one piece. But just for the teams that's like out of the box, I want it to work and I don't want to deal with it. I think it's a better solution than Elastic or Solar. You end up spending a lot less time and headache.
Yeah, that's amazing. That's so deep. And in what you said, speaks and sings a practitioner, but I think also speaks and sings a dreamer. I think you dream of better ways of searching things, right? And that, like you went through it practically, but also when you get so deep into practical elements, you get stuck into it, and you're thinking in the framework of the given system, of a given language, even, right? Sometimes the paradigms that you read through the docs and you keep thinking about them, it's hard to unstick yourself from them. And I mean, the fact that vector search field was born is magical in many ways. So I feel like you feel the same. And I mean, the fact that you also ventured with me and others into building a new algorithm for vector search also says that you wanted to go as deep as implementing an algorithm, right? So what could be sexier than implementing an algorithm? I mean, I don't know. Of course, all other things are also sexy, but I'm just saying that it's very complex. It's very like demanding, intellectually demanding work. So that's amazing. Thanks so much for this depth. And is there something you would like to share or announce with on Mighty, or maybe on something you're going to be presenting on Berlin Buzzwords, I know as well, but is there something that you would like to share?
Yeah, so I am presenting at Berlin Buzzwords. I am putting together a charity event to hack on vector search, and that's going to be on May 5th. I don't know when this podcast will be published, but on May 5th, I want it to be, it's just going to be an all-day learning session on, and I'm not charging money for this. This is like free. I just want to show people how to use these tools. If you're not in the Python world, if you're part of the Python world and you want to join, amazing, great. But I want to do an all-day like hackathon where I'll show you how to get these things up and running, hack away at it. By the end, you'll have a working example on your own. And all the time we're going to raise money for charity, specifically around refugees and displaced people, because of the horrible things that are happening in Ukraine and other parts of the world as well. Getting some learning happening and also raising money for charity seems like a great way to spend time. I plan to host that on May 5th. It's probably going to be on Twitch because I want to just to be an open drop in, drop out format. You can come, you can go. It's not going to be like a controlled Zoom where it's like that. It's going to be on Twitch with chat and stuff like that. So I'm gonna get it all set up. The details are going to come out shortly. By the time this is published, maybe the details will be available already, and we'll drop a link.
Yeah, awesome. This sounds amazing that you also keep thinking about this sensitive topics or like what's happening in the world, and you are also contributing with your skills into a good cause here. Thanks so much. I will try to publish this podcast before May 5th to make sure that somebody can join and catch up. And of course, we can do the mass media, social media push. This is amazing. Thanks so much, Max. I've enjoyed this conversation thoroughly. We went into depth and width and everything, all dimensions. It's a multi-dimensional conversation. So thanks so much and keep it up. I'm curious to hear news about Mighty and the tooling around it, and also looking forward to your Berlin Buzzwords presentation.
Yeah, thank you so much, Dima. It's great to chat.
Yeah, thank you, Max. Cheers.
Cheers. Take care. Bye-bye.